Okay, a couple more questions. Why do we have more pseudocode instead of actual implementation of data structure in the latter half? That's just because of the fact that we are trying to focus more on the build your own world stuff. So at that point, I'm trying to engage more with the software engineering material, and I'm hoping that you've gained the skills you need to fully digest the things that are just pseudocode. Edison, go ahead.
Yeah, I was wondering, I've been in Utah this whole semester at Brigham Young University because Berkeley's like closed. And I talked to some CS kids here, and they start with like C++ in a lot of the lower level classes. So I guess I was wondering why we start like at Python and then work our way down instead of the other way.
Well, actually, I've even seen people start even lower than that. Where you start with logic gates and transistors and that sort of thing and work your way up, which is the motivated bottom-up approach, which I know like ELPAT at UT Austin was a strong proponent of. And I guess that was kind of my experience as an EE undergrad. I like Python, actually. I think it's the perfect starting language because it exposes just enough of the model of computation of how a computer works to allow you to build anything. I think starting with C and C++ is, I don't like it because it's too low level. It's like, it's just the abstractions are too detailed and it gets in the way of trying to understand decomposition, in my personal opinion. Like Python's just more fun to program in, you know. It's like very easy to remember how to open a file and read it and do anything. It's like almost like English. And for that reason, I love it as an intro language. Yeah. But, you know, C++ is fine. Okay, how to make sure 61B is in pace with other courses at Berkeley? What do you mean by, oh, no missing gaps and repetition? Well, I mean, part of it is I just look at the downstream and upstream classes. I mean, like I've looked at 70s course material to make sure that I'm not going too much into graphs and PNP. I look back at 61A to make sure that my asymptotics isn't, you know, that it's a little heavier than what they have traditionally done. So it's a little bit of work on my part. Yeah. All right, any last questions before I move on to my other thoughts? This is the open-ended a little bit. Okay, cool. So, oh, favorite CS class, 61B. oh, we'll talk about Gitlin. I'm not necessarily getting rid of it. I have an anti-Gitlin bias. I've always had an anti-Gitlin bias. I'll probably continue to have one. I'm willing to keep it though, if you guys like it, right? Because I survey the hell out of you because I want to know what you think. Okay. Yeah, oh, that's so funny. I mean, I wish there was just like statically typed Python. I would enjoy that. Yeah. Well, here's the thing though. I'm gonna wait to see what the survey says, but students in the past have loved Build Your Own World so much that I'm loath to take it away. I was a little stunned by how much people liked it back in the day. What are my thoughts on open sourcing material from Berkeley courses? Well, a good enough topic of how my class is designed, I guess, but I will say that, what do you mean by open sourcing material? Like building your own class based on the classes? Oh, I love it. I want to do it. I will eventually. All right, we'll talk about removing things too. But yeah, I would love to get 61B even more out there in the world. Okay, cool. So let's talk about the history of 61B real quick. I won't belabor this too much because it's not that exciting to you. But you know, I first taught 61B on my own in spring 2015. I co-taught with Paul Hilfinger my first semester at Berkeley in fall 2014. In spring, I took over 61B. So I created 4 new projects, but I had a lot of help from students. I delegated a lot because I was building so much content so fast. It was a crazy marathon. Project 0 was something called bomb checkers, which was you implemented checkers from, you know, pixels. That was kind of fun. And it was like an alternate rule set. Project 1 was something called NordNet, which involved database manipulation or data set manipulation. I put that one all together. I love that project. Project 2 was the first Gitlet. Joey Mogadam entirely conceived, implemented, and wrote the spec for that original version of the project. He was later the summer instructor. And then project 3 was just me gluing together some old Princeton homeworks into a project about tries. Now, I want to talk about one of the biggest decision points about 61B. One of the most important ones is how hard the project should be, what their nature should be. And so I'll say first that the spring summer 2015 Gitlet was just like way too hard. It was insane. Like there was no testing provided at all. We had no testing infrastructure. We gave no debugging infrastructure. It was just, you know, go do it. And there were no tips on persistence. So we didn't have a persistence lab. And partially that's just, you know, I was getting my feet wet with Berkeley And what's funny is like when we got through the project, the students did it, but I think it was a somewhat miserable experience for everybody, more so than this time. So then we got to 61B, what I think of as version 2, when I'd hit my stride. And I basically had this observation that I hated, that students had to split their time between all the core data structures content, hash maps, binary search trees, priority queues, and then some huge project that wasn't really related to that content, like Gitlit, and also the projects that I did with Paul back in 2014. I mean, they weren't unrelated to data structures. They still helped you learn like how hash maps are useful, but it wasn't reinforcing the lecture content, which is, what's tested on the exams, what people will ask you about when you go to job interviews. And so I decided, what I'm going to do instead? I mean, people seem to really like the messy real world project. That seems to be like a thing that I get again and again and again. So I'm going to make that due right before data structures start. 2016 was build a text editor in Java, where you could set the font size and whatever else. It's kind of cool, actually. It was really interesting. And it was supposed to basically teach you the same sort of things that Gitlit does, which is, how do I build a big piece of software, right? In 2017, it was, okay, let's make it a little more data structure-y. And so we had something where you could read in CSV files and do joins and whatever else. If you've taken, if you've ever done data science type classes, you know what I'm talking about. And both of those projects worked, relatively well. But there was an interesting experience that I had again this semester, which was that there was a certain subset of the students who just had a horrible time with these projects because they took so much time to get started on. That's the key thing, right? Like long specs, just the startup energy is massive. So there was this round table I held where I randomly invited people to a room back when we could get together in rooms, and I grouped them by quartile based on their exam score so that so people would feel free to speak their mind, not feel like, oh, I'm way ahead or behind to someone else. Okay? So roughly speaking, my students said the following: the top quartile about the really big Gitlity project was, we loved it. It was not really such a big deal. Like, I got through it. It was not an especially large burden on my life. The second quartile students, more or less, this is kind of a summary of a lot of people's opinions, was it was really hard, but really rewarding. But, again, it wasn't like life dominating. The third quartile said, well, we spent every hour thinking about it. We were dreaming about it. It was a, amazing rite of passage, and they managed to just barely make it. It was miserable at the time, or sorry, it was kind of miserable at the time, but once they were done, it was just amazing and they were exhausted. But then the fourth quartile, for the most part, I would say that it was an absolutely miserable experience. They generally didn't even finish. They felt like they got like a very low score, spent tons of hours and ended up with 10 out of 50 points or whatever the points were back in the day. And they just didn't really feel like they made progress. So what I decided to do was tone down the project for the third version of 61B, which was the last 3 times I taught it before this one. Yeah. So roughly speaking, there were 2 big projects. One of them was this highly scaffolded project called Bear Maps, and it tied into the course content really tightly. The goal was, I want you to have that DEX-like experience where you do the project and then you really understand some stuff from the lectures. So there was implement a KD tree, but there was no autograder. So you had to do your own testing. This caused a lot of anxiety, but it was also a little bit about testing. Then there was design a priority queue with an extra feature, no public autograder. Use your priority queue to implement A*, use the KD tree and A* to implement this Google Maps thing, right? It was cool, I liked it. But I had this persistent complaint, not from the students, but from the TAs, that there was something missing here, which was this open-ended experience that you got with Gitlit. Yes, you understood KD trees and A* and priority queues really deeply, but you never really struggled in quite that way that, it's like real software engineering where the whole scale is falling on you. Now, it's not that you didn't have that experience at all. You did on Project 3, which was build your own world. But because Project 3 gives you so much flexibility in what you can do, they felt like it still wasn't quite the same. That, Gitlit, you're like shackled. There's a specific thing that you must do, and it's very big. And so I said, okay, I see what you're saying. I'm going to try and make it work. Let's try just swapping out Bear Maps as an experiment. I was going to adapt my old NordNet project, but the TAs pointed out, hey, we already have this out-of-the-box project called Gitlin, right? And even though I don't like Gitlin, let me tell you why I don't like Gitlin. I don't like it because I find it a little dull. Like, the thing that you build, it's cool that you built Git, but I just don't feel inspired by it. That's just me. Maybe you love it, because once you get really attuned to something, you like it. And it is, even though it is decomposable, it's just not quite my style. It's a little too decoupled from the course material. But as they pointed out, we have tons of support resources. We made all of these videos. We've made all of these debugging tools. We made all of these testing tools. Let's just use it. And so I was like, okay, I have a lot of time constraints right now with limited childcare and all these crazy committees that I'm involved in right now. So let's do it and see how it goes. Okay. And it gave you a lot of room for creativity, and hopefully was fun. I'll also note that we changed out Project Zero to give it a harder algorithmic design challenge than the old Project Zero, but that was a small change compared to the Gitlin one. That's the big change of the semester. Okay. Stockholm Syndrome, I see. So that thing where you wake up at 3 in the morning and then you fix something, I think that is cool. I love that, getting so deep into a problem that you dream about it. Okay. Now I just gave you the history of 61B to give you some insight into how I change the class every semester, but realize that it's not just my decisions, but decisions that TAs recommend or even just make. There's like 40 plus people over the course of weeks. So really explaining exactly how the magic happens. It evolves. But if you want, just in case you're curious, I actually every semester, and I'll do it again this one, have a reflection slide where I say, for example, what changed this semester. Okay, wait, this is the spring 15 one. So these are things that I changed in spring 15. And then these are the things that I intend to do next time. And each time you can see the things move from one column to the next. So for example, in fall 20, the things I proposed doing, just to look at it. Oh, this is what we changed. Okay. So move straight to IntelliJ from day one. We did that. That was new. We ended up killing Project Zero entirely and changing it to a new one. We did make Project 2 into more of a design project. I don't know that we did a great job with helping people find community and study groups. We tried. And we did make Project 3 run multiplayer. So, those are those changes that end up being suggested. Okay. So let's talk a little bit about Gitlin. Oh, nice. Okay. I like that you did actually show them Gitlin elsewhere. Yeah. Okay. Sorry, just look at the chat real quick. Right. So we're talking a lot about community shortly. But first I want to talk about Gitlin. So as I mentioned earlier, the spring-summer 2015 Gitlin was too hard. And so things, changed over time. But basically when I ran it that semester, I was a little burned out on the project afterward. I was kind of like, I'll shelf it. It's fine. I'm probably not going to use it. It's kind of sat around for a while. But in fall 2017, Paul, who every semester tends to change out his projects, decided he was going to use Gitlin. And actually since then, every summer and almost every Hillfinger semester, he's offered Gitlin. And so it's become the core staff knows, because they stick around even when we change instructors, they know this project very well. Okay. Now, as I mentioned, in response to TA concern that bare maps, it was too painting by the numbers. Like here's KD tree, implement KD tree. I tried revamping the spring 15 project, but I didn't have enough time to get something I felt good about, and so we did Gitlin. Okay. All right. So just to remind you of where that went. So one thing we did this semester is we had everybody install snaps. I know it's a little invasive, but really we're just looking at your data in bulk, and it was so helpful. So if we look at the time people spent programming on Gitlin, this is just the time you spend in IntelliJ. This does not include the time that you spend, thinking about it or reading the spec or watching videos. But roughly speaking, this is the distribution. And obviously these people didn't finish the project because they only spent a few hours on it. But among people that spent at least some amount of time, the median was around 31 hours of time in IntelliJ. People at the 25th percentile mark, it was 20 hours. And people at the 75th percentile, it was 42 hours of time. Okay. Well, we infer it through snaps. We actually don't we don't run a timer. So this is all just inferred from the snapshots that it takes, but it's pretty accurate. Yeah, I can let you know. Maybe we will provide you guys an interface to see how long you spent. Snaps works where every time you save or compile, it creates a snapshot. Yeah. It doesn't, yeah, so it doesn't, this is only active time and it may include some dead time. Yeah. Anyway, right, so, we can see there's a spread. It's not quite as huge as I had feared. 20 to 42 hours between these two quartiles. It's not as bad as I had thought it might be, but it's still a lot of time. I think it's too much time. Let me tell you why I think that is that this is only the time in IntelliJ. And roughly speaking, let's say that the median person spent 30 hours. That means that 30 hours plus whatever time you spend elsewhere, maybe it's 50, 60 hours, something like that. It's just too much time, even over the course of 5 weeks, I think, personally. So could be shrunk. No one finished in 2 hours. I couldn't finish in 2 hours, not even close. We asked students, what did you think about Gitlit? Was it a healthy experience for you? Well, there was some mixed opinions. I would say there's a big chunk of people, 36, 37%, who disagreed, didn't feel like it was healthy for them. And then, we got this slightly larger chunk that felt like it was healthy, and this number neutral. Now, this isn't like, is it good or bad? It's like healthy experience for you. So this is another reason why I feel like, at least in its current form, like Gitlit's just a little too heavy, because I feel like in a introductory course especially, like this is just, I think I'd like to see these numbers much lower for unhealthy, right? Yeah. This survey was in the week 13 weekly survey. It was one of the questions, week 13. Yeah. I also asked, okay, well, like this is a hard question to ask the hypothetical about, but in spring 19 and fall 20, project 2 was a project which was basically like a double linked DEX. I explained it to you guys, this bare maps thing. If you could pick, which one would you choose? And so it was a little over half strongly preferred Gitlit over something that was like a double DEX. And then actually only a relatively small minority wanted a DEX style project. Okay, so that's useful to know. Okay, let's see some comments. All right, I should have probably animated these, but I'll just read them. I know you're gonna read ahead, but here they are. I just excerpted some random ones. This project crushed my entire soul. I hate it, but now that it's over, it was such a good learning experience. OMG, like what the heck was that? OMG. I mean, I get that. And one of the most interesting questions to me about education is, should anyone ever feel this way? To be broken and rebuilt, right? Because in some sense, it's beautiful and amazing to imagine something that you are benefiting from, that you're learning from, that like is that intense. It's cool, but also scary, especially if you don't make it through. Here's some negative one. I'm sad and have to switch majors. I was in love with CS, but now I hate it. I guess everybody changes, but it was sad for me to let it go. Goodbye, coding. While it was a horrible overall experience, I'm grateful that I did half of Gitlit because I'm now confident that I never want to work in software engineering. I can't believe people spend more time looking at how to use random crap in Java than actually thinking. And I'm going to be showing you 3 pages. This is not the only ones. Wild. I just have never felt so stupid, but once I got it, I felt good. I don't think that's healthy, but that's the truth. So these are some kind of negative skewing, but there's a couple people that it was worth it in the end, and 2 people that we just shoved out of CS with the experience. Okay, I think it was an amazing project. I do think that when you first start it, there are many students who would be too intimidated to start. Lots of people, right? I feel intimidated when I start looking at the spec. Or may set them up for failure because the increase in difficulty from project 1 to 2 is insane. I hated the project at first and it was very detrimental for my mental health, but I came out of it feeling so good about my skills. Or I think after you finish Gitlit, your confidence improves a lot. I didn't think I would ever be able to code something like this, but initially it was a painful experience. Once you get the hang of serializing stuff, the design is probably the hardest part. And then a project about Git seems like a really shitty project when you first read the 60-page long spec, especially from someone who didn't know how to use Git. But the creativity and building that goes into it makes it a really rewarding experience. I loved it. This is the CS162 experience, by the way. I want to say, coming into college, I'd never coded before. I was super daunted by just looking at the Gitlit spec when it was assigned and kept on pushing it off. But now I'm proudly able to say that I have finished the project and it has truly given me a lot of confidence in my ability to code and think through lots of things at once. So I give you these examples of quotes because I read all of them and trying to weigh all of this, because let's be clear, there were 2 people who were interested in CS who, because of this project, decided they do not want to do CS. That's in the negative category, right? And I have 13, 15, 1,700 people that I'm responsible for. And so decisions I make are going to affect, like, if you figure 30 people, or say 30 hours, 40 hours times 1,000 people, I'm deciding how 30 to 50,000 hours of human effort should be spent, when I decide just on the Gitlit project. So it's a lot to balance. It's a very interesting challenge and intractable, and hey. All right. I asked this question on the survey. This was the word cloud I put together. Merge command. It was all single word. So this actually it wasn't really merge command, but yeah. It's the only thing that seemed to be consistent among the word cloud. I don't really a big fan of word clouds. First one I've ever made was merge, but you can see this other stuff. Anyway, what people had to say. Nothing. Global log. Oh, that's interesting though. Why are they together? Yeah. Gitlin. Yeah. Okay. All right. Let's talk about the workload overall. So I am sensitive to the fact that you're young people that have a lot on your plate, and you'd probably like to also enjoy, you know, being out there doing fun things. So, and maybe not, sorry, I should be clear. Not literally every single person in the class is super young. I know that there may be at least some other people my age, but I recognize a lot of people are, you know, getting used to adulthood and you have other things you want to balance. So in theory, Berkeley says a 4-unit class should be 12 hours a week. So that should be 1 hour discussion, 2 hours lab, 3 hours lecture, and 6 hours everything else. That includes check-in exercises, studying, surveys, homework projects, etc. So total time spent programming should maybe be, I don't know, 6 hours per week. 2 lab, 4 everything else overall. And so I wanted to know, one of the main reasons I put together Snaps, like why Snaps exists, is I wanted to know how well I'm doing meeting this goal. And actually, I was encouraged to find not too badly, right? So this is a box plot showing how much time people spent in IntelliJ every week. So in Project Zero, this basically is annotated. So Project Zero, you can think of this as the distribution of time people spend on Project Zero. This is the average. These are the quartile ranges, though I don't remember if it's like 25, 75 or what exactly. And each of these is an outlier here. I guess I should have looked up what settings I used to generate this plot so I could interpret it more clearly. But I'm just looking at the averages, to be honest. And so overall, on average, people spent around 4.5 hours a week doing some kind of programming. Obviously, some of the weeks were a lot busier than others, but it seems like we're actually doing okay, right? Like my rough sense that people should spend 4 hours, 6 hours a week doing some kind of programming. We're in that range. You know, this is not 100% accurate because it only includes time that someone's literally like coding in IntelliJ and saving and compiling, but it seems like we're in roughly the right ballpark. Yeah. Oh, thank you. Okay, 1.5. This is not R. This is all pandas. This is the data 100 stuff. Yeah. Anyway, so in case you're wondering why I'm like so annoying about asking you questions on survey and making you install tools to watch you, it's because I use all this data to decide what the hell to do. Because otherwise I'm just running blind. And this is the first time I've had this plot, and I find it relieving. And I would be so curious. I mean, I suspect that other classes, I mean, I already thought that I was pretty much in bounds just based on how the HKN survey relates to classes like 61A and just anecdotally. But you know, my perspective gets skewed because I talk to these people a lot, right? Like I interact with the students who are spending way more time. It's because they're the people who like come to me because they're getting annihilated by the class. So, you know, one of the reasons I also try to collect data is so that I'm not just skewed by the people I tend to interact with, who are most often these, and then, you know, sometimes these people who are very fast. Okay, cool. Seaboard, thank you. Okay. All right, I got one more topic I want to talk about today. It's a bit of a lateral move, which is just the role of community. We were talking about this earlier. People were talking about the Discord. Okay. Yeah, actually, as people are noting, 70 and 61C are both considerably more difficult than 61B, right? So I think I'm pretty happy with where 61B is. As a member of the community, once you finish 70 and 61C, if you don't like it, just make sure to let the world know. I don't know what the right answer is. I've never taught either of those classes. So, hey. All right. So, and of course, students, they benefit from networks of support, obviously. I mean, some people solo it, but most people will tap into some kind of network. There's the formal network, which is office hours, ed, discussion, lab, your project partner, whatever else. And then informal is just whoever you talk to in, say, a dorm that you live in, or on the student-run Discord, or in the room where office hours happens, even though we don't really do that much. Now, I personally believe that these networks are actually an enormous impact on success, one of the highest order bits, so to speak, right? Students who come into the class with weaker backgrounds and no support, they will, like, your chance of succeeding is much lower than if you have support. It's so important. And you know, all of these things, we try to foment community and make good community, but we don't always do a perfect job. Yeah. Looking at here. Okay, yeah, 70 discussion happening. So I'm kind of curious actually to ask you, what are some things whenever you were working on your project partner just to get a sense of how the project 3 partnership worked out. What are some things you learned while working with a partner that maybe work more on the soft skills angle? And that's a weird question. If you want something, do it yourself. I learned nothing. He has different strengths than I do. One, I learned nothing is because you had no partner. I had no partner. If you want something done, do it yourself. Not a good thing to have learned. Bummer. We have different strengths. Other people don't stay up until 4 a.m. People program differently. Working in groups is hard. It is often hard to explain what you are trying to do. Sticking to a schedule is good. Going over design with someone is good. People program at different paces. Programming, yes, I know that one well. Programming in front of someone is harder than by yourself. I know that so well. Like programming, live coding is so stressful compared to just programming by myself. Let's see. These are good. Arguing for 3 hours leads to clean ideas. I like that. Can't be silent when wanting. Can't be silent when wanting to think. I wonder the part of we can't really just be silent when wanting to think. You tell us when thinking. Okay. All right. Feel compelled to share thoughts as thinking. Better to have one commanding, other typing. Commenting is necessary. Okay, I'm just transcribing chat comments here. Hard to read someone else's code. Also your own code 1 month later, by the way, because that's basically someone else. All right. Neither of us know how to use IntelliJ. My spelling is bad. Okay, yeah. Merge conflicts are tricky. Let's see. Oh yeah, searching Stack Overflow is embarrassing. Okay, cool, great. So I hope that the partnership experience was, you know, a valuable thing. I have thought about having more partnerships in this class, but I kind of want to make sure everybody builds the core skills. So that's something I've often debated. Okay, I just wanted to talk about that. Okay. So some general team, these are some tips that one of my TAs gave me, like kind of resonate with things you were saying. So, you know, for the future, things I felt like make for good partners. One was, you know, be upfront about what you can and cannot do. And your communicating is really, really important. And it can be awkward. You know, if I'm a student and I perceive myself as weaker than my partner, it's weird to broach that subject. But you know, as some of you learn, people program at different paces. Another is don't ghost your team, of course. So we had that happen with one of the people in chat. Make sure to respect other people's ideas and contributions. So, you know, especially when you get into these bigger 4, 5, 6 person projects, it's important not to talk over other people, and you're gonna have to make compromises. Maybe that's less important for pair projects, but it'll be important later. Here's a funny one that I am often not good about with my TA staff. And it's surprising because, you know, we get in our own heads when we're working on these big projects and we don't think about what other people are like feeling. And so it's important to really acknowledge and support what other people are doing. Like saying thank you when someone else does good work actually is a huge deal. It's like so small. And some of you may have been brought up by parents or whatever, your social environment to do that. But it's funny, like it's not something we would teach you. And, you know, maybe wondering like why I'm talking about this, but if not me, who? Managing implicit bias is pretty important. And, you know, we all have some degree of implicit biases. Maybe in your partnership that didn't come up, but this is something that'll come up, you know, especially in your career later. And if you're ever in a big group, it's important to actually stand up for other people whenever you need to. Okay. And again, these are just general tips my TAs thought would be fun to share. Okay. Do I want to do this now? Let's see. I guess I do. I think we have time. Okay. Thought about doing this in the last lecture, but maybe we'll do it now. Yeah, positivity. It's good. Okay, one thing I want to talk about was something in the survey. So there were 92% of students, this is kind of related to this whole culture, course climate angle, reported seeing at some point in a CS class some kind of hurtful behavior, or I hate the term microaggression personally, but something like that. Like the reason I don't like that term, by the way, is it implies malice. And I think it turns people who might otherwise be open to listening to you about them to stop listening, especially if you're from sort of a, like I grew up in Texas. I very much understand like the conservative mindset. And there's I think language really matters. Anyway, there's an emerging term, especially in this space, which is subtle acts of exclusion. Yeah, it's a mouthful, Okay, here's a whole book about it. If you're curious, like why this is a better term. But I think people are more willing to work on the problem if you point out that a subtle act of exclusion is, I don't know, you may disagree, but I see this term increasingly in this one less. My own personal bias that I don't like this term much. Anyway, so people listed some examples of these, acts of exclusion or hurtful behavior. So, for example, one time I went to office hours and the tutor said, "Oh wow, you actually understand what I'm saying." And in this case, the author said, "Well, I'm female. I don't know how to respond. Like, I don't know how to feel about that since I'm a woman." I think what the writer is trying to say is like, were they like surprised I understood it because I was female? Or I've not experienced anything super explicit or egregious, but it's no secret that CS classes and spaces are a bit of a boys' club. I felt talked down to, or I felt talked down or underestimated as a girl in CS spaces, usually from male peers who feel like they know more than me or more qualified. A lot of boasting. Like you're in lab and somebody finishes early and they make a big deal of making sure everybody knows that they're out of there in 20 minutes. Or another one. This is an interesting one about informal spaces. I wasn't there, but perhaps many of you saw this. So there was a person in the 61B Discord who was making inappropriate comments and jokes about harassment and eeks after a person shared their personal story about being stalked by a CS GSI. They made jokes about how it's okay or normal for people to become GSIs to get girls and said you got to respect your GSIs. I felt like they were making a joke out of people's sexual harassment stories. After being called out for being insensitive, they replied that people should be able to take jokes and called the person who called them out ignorant, right? Now, what's interesting is I actually, like, if I put myself in the mindset of, an 18-year-old guy, I can see why can't you just take a joke as a reasonable perspective? And as somebody who actually was part of a comedy group whose goal was to like push people's boundaries and even be offensive at times, I will just say as an older grown up, I don't know, I actually think I disagree pretty firmly. So it's just not the right place, not the right attitude generally. Personal opinion. Another example. In an upper div last semester, I was in a discussion with a female TA who was a PhD student, and male students would continuously ask if she was sure about her answer when she answered their questions and seemed to always doubt that she was answering correctly. And then someone else mentioned, it was weird to get these things, but other people called it out. So I was glad to see that. Okay. So why am I bringing this all up? Well, I was going to ask you some questions about this after, but I'm going to end here, which is basically why are we talking about this right now? Like, why are we talking about this topic in a highly technical advanced data structures class? I basically have two reasons I wanted to bring it up. One is that, we're all citizens of the university, and I think it actually is something we need to do to make our community a good place for our fellow students. And who is a better person for me to talk, who's better to talk about this than me? Like someone you can trust, presumably. I feel like it's a little bit of my responsibility to say I actually don't think it's a good joke here or whatever, right? I get it, the idea of exploring comedic spaces where it's edgy or whatever, right? That's part of what comedy is to be unexpected and push boundaries. But you always, in anything, right? When I think about this class, it's always about balancing harms and positives. And it's just, it's not an acceptable way to be. And this is just but one of many examples. There is so much here, right? As part of being an adult and being a person in the world is I really think it's important to understand your own mind and to understand where it is that you're biased, ways that you're harmful, and fix that. Nobody's perfect, of course. We all evolve over time, and that's in a way one of the goals of being at a university. And again, it's not the core topic of 61B, of course, but it is underneath this class and everywhere we are. So I guess I'll close by saying, as my GSI Allison puts it, a good programmer is not just someone who can solve a coding problem or ace a test. You need to be someone that others actually want to work with, someone who's contributing positively. Okay, so on that, I'll close it out. And next week, we're going to have two, just normal live QAs Monday, Wednesday, and then we'll have a live lecture on Friday where we'll talk about the class as a whole, but we'll do a little less metacognition about how the class was designed. So let me know, of course, in the survey next week what you thought of this lecture. It's a very new, strange type. And I'm happy to stick around for a couple minutes if anybody has any questions. But here, I kept you an extra minute, so feel free to stick around. Okay, bye, everybody. You can go, but I'll have to chat. Okay. Any questions anybody wants to bring up by raising hand? Oh, in the recording, in case you have anything touchy you want to ask.